we're going to have a very interesting talk for the mariners. And I would say that using Jørgen's, one of Jørgen's favorite tools, I was absolutely shocked when I followed the Costa Concordia YouTube broadcasts, and then I got to realize, way before the reports about it, how incredibly terrible the alarm handling was on Costa Concordia. Because basically when they hit the rock, there were so many alarms, so many vendors going off at such a frequency that you would either have to leave the bridge or be the most, I don't know what, person to not turn completely insane.
That would definitely agree with that. Was definitely far too much noise.
It was definitely in such a way that I think it's already been mentioned by some preliminary investigation that the alarm handling on that ship was so poor that it actually gave the crew a very hard time to obtain situational awareness and really register what is going on. So it definitely didn't help. Now, the distinguished guest from Norway, Geir Hasnes, has been working many years at Sintet. He is now with Kongsberg Maritime, and he's also lecturing still at the University in Trondheim, so he's going on the path between Kongsberg and Trondheim. And Geir has been the principal engineer at the cybernetics group at the Kongsberg Maritime, and I believe, maybe I'm just here, but quite a bit of this work has been done in the EU project, right? So his contribution is about alarm filtering. So Geir Hasnes, welcome.
Well, I hope you can hear me well. I will talk a little slower because there is much echo here. We will try to avoid the feedback. I have a distinguished accent from North Norway, but it doesn't include the feedback. This is probably due to us who were born in North Norway, that we have a quite different environment. There is much snow and ice, and there is very little feedback from snow and ice. So there is not even feedback from all the reindeer that you heard, and the polar bears and things like that. I actually learned at a very early age how you survive a polar bear attack. How do you prepare for polar bears? And you might not know it. So if you don't know, it's very easy for you to be eaten by a polar bear when you visit North Norway and so on. So maybe I should teach you the trick. The thing is that, as my parents told me, when you go out, you always bring a smaller friend. I hope you got it. And if you didn't get the point, well, bad luck to you when you visit us. So, I'm going to speak about alarm filtering and what it's all about. It's really alarm to the arms. The French cry out. It is crying out, grabbing the attention of people. It's all about grabbing the attention. So, in order to demonstrate this, when there are only men in the audience, I used to bring a slide of a Playboy girl. Because when you bring a slide of a beautiful woman, when you are supposed to talk science, then you really grab people's attention. And that is what alarms are all about, to grab our attention. Alarms are simply something that shouldn't happen, so it shouldn't be the normal situation. But aboard our ships, our vessels, our oil rigs, thousands of alarms sound the whole time. So they become the normal thing. They become the normal environment, and there is no reaction to it. So how to make alarms uncommon? First, I have to say about innovation that we have to be clear about what innovation is. Creativity is in the generation of ideas. and I generate a new ID every second in my waking state, and even more in my dreams. But one thing is to have an ID, another thing is to put it into a product, to put it into use for others. That's where innovation comes in. And I actually could add, there is no such thing as systems engineering. Systems engineering doesn't exist. Innovation exists. What we call systems engineering is nothing else than taking an idea and putting it into a product by coding, by models, etc. But it is innovation. So innovation needs models, it needs principles, it needs concepts. We need to agree on these things, and without a common understanding, we can't share, we can't have any open innovation. So actually, the Norwegian Petroleum Directorate, they made this model for alarm handling some 11 years ago, and it has become so common that oil rigs today, which are built in Korea for the North Sea, these oil rig builders and the owners, they demand that we comply to this process. So you can see there's a lot of mechanisms. You have a signal filter, you have an alarm generator, you have what they call an alarm filter, where you can trash alarms that are unnecessary. You have an alarm suppressor. So suppressed alarms will go to the details for alarms. Then you can shelve alarms by operator input. So the irrelevant alarms are shelved, and the relevant alarms at the left shall go to some sort of overview. So this was the process. They call it an alarm philosophy, and it was put into, I think, 43 parts. It was called how to alert. And in IOOI, they wish to use the word alert instead of alarm, because alert includes warnings. It's the philosophy which are required from us as a manufacturer of systems. How are alarms logged? How do they support operators? How do you minimize the human limitations? How do you prioritize the alarms? And how do you acknowledge them? Which standards are you going to use? Which general principles are you following here? Etc. etc. This is what is contained in an alarm philosophy. So the European Union had a huge research program called Flagship. We were the sub-project there. We had the parts B4, E1, F7, and G7, which will not tell you much, but I could not say only part B4, which was the 20th part of etc. So from January 2008 to June 2011, I researched these things. We had with us ship owners, TK, a very, very large ship owner in Norway, fleet all over the world, and we had the Greek ship owners, ASV and Mina. The Research Institute of Trondheim Marine Tech also participated with Ernst Brødseth, if some of you know him. And we had another industry company do the Atronica Fire and Security, which delivers fire alarm systems to all kinds of huge ships, huge cruise ships they have there. And it was supposed that the TEDIC process should be a basis for this project. And it also goes, reduce the number of distractions on the bridge related to alarms. And be aware of the word distractions. I don't know, by the way, if you know what that distraction really is. It was in Greek, when they wanted to silence some distraction. They actually took him out like this and to 4 horses, and the horses went each their way in 4 directions. So in this way, the guy was distracted. That's where distraction comes from. So quite brutal, and it's good to know you're Greek, you know. So it's not that bad on the ditch actually. Only afterwards, when an oil rig has gone down to the bottom of the sea and so on, then some leaders are going to be distracted. So you have to make alarm management more efficient by, for example, integrating maintenance support systems with the alarm system. And we got some clear goals here. Reduce bridge alarms in a given scenario, for example, breakdown in auxiliary systems, by 80%. That's the alarm flooding situation. Also to reduce bridge alarms in a general operational scenario by 20%. And build a prototype system in order to demonstrate concepts. And I wouldn't have been here if we hadn't solved this. So you can rest assured that now you will be told how it all went. Our activities, they are in a way important because this is about philosophy. We did an analysis of ship types, of different ship equipment, of modes of operation, and from this we made our alarm system concept and we built the prototype. We did an integration phase and we tested and evaluated with the ship owners and we did a demonstration. And after that, I must say they rather threw money after us to disseminate the results. It was what I, as an English understatement, would say a tremendous success. So the general alarm process is watching the system continuously, processing information, generate alarms, structure them, present them, and handle them. The process model had to be expanded. And we also will show how we peel out things in order to reach our goals. You can see the feedback loop, the analysis and tuning. You can see that I have put some numbers in here and there, so on. But this is the main conclusions. I should actually have put them on one slide each, but this is summing up well. So, alarms can't be understood without the routines on the vessel. The achievement of an alarm is in the corresponding routine. That is the connection with people. And without routines, alarms are simply meaningless. It's meaningless to have an alarm and don't know what to do with it. But this is what we also came out with. Different ship types don't influence alarm handling. Different ship equipment don't influence alarm handling. And different modes of operation don't influence on alarm handling. And we can discuss this later on. The alarm sound is the major problem ever. The alarm presentation and understanding is the next important problem. Alarm suppression by using first group alarms solves the alarm flooding situation. And brilliantly, I have to say. Alarm shelving solves the problem with spurious alarms. And spurious alarms are that sort of alarm that comes every now and then because you have a certain sensor on the deck that tells that this thing here is not completely closed, we cannot do anything with it until we have come into the harbor. We cannot repair this now, so forget about this. Why can't we silence it until we get into the harbor? And the centralized overview screen gives the situational awareness. And I am aware that situational awareness is some sort of catchword. It's some sort of cliche. But then again, cliches become cliches because they are, at the outset, something very well said. So, the situational awareness here is so obvious for sailors that they tell me that I think there was one guy, he said, he can't live without this system after having seen it. So the alarm groups, they must be taken care of. We will come to this. The status is that the prototype system has been implemented in all these mechanisms in our AIM support system for our systems. And we have proposed a screen protocol and the HMI. And when I say proposed, it's always proposed before the design people have had their hands on it. So you can solve the problem, but the design of how it should be solved can go on with discussion for each. The ship owners have all said, this is what we want, where can we buy it, when can we have it? And the demonstration was a simulation of an actual system from an alarm clock. We had a boat in the North Sea. They had a battle that lasted for 4 days. And we also had 7 days normal running time. And so we had to limit this to our Kongsberg systems and to the alternative fire system. And of course, we have actually made demonstrations, we have made a promotional movie, and we have a demo room at Kongsberg where we can show people these things. This is what we came up with in practice. We will not trash any alarms. If there is an alarm, at least log it. We put alarms into groups, and this is something that will be convenient to do together with the ship owner. So you use the first alarm in any group, because that is the only alarm that can be understood completely. It is not ambitious. All other attempts to make some sort of collected alarm is ambiguous. It cannot be understood 100%. But the first group alarm gives you the understanding that something's happening here, research. The shelving by the operator takes care of all these spurious things after the group alarms work for themselves. And we made another screen, actually, which gives the overview, and we will show you those. This is something that I think should be more like in textbooks. But what we found is that there is a different understanding of silencing, of acknowledging, or resetting, etc. So therefore I made this figure. From no alarm, if there is an alarm, you put the buzzer and the flashing light. When you push silence, you silence the buzzer, but the flashing light is still on. When you acknowledge it, that is, you have taken care of what is the alarm actually reporting, then you have a steady light. And then comes the reset. That is, it can be manual or automatic. In case of fire systems, you always have the manual reset, because the sensor may simply be burned up so that it doesn't give an alarm anymore. That doesn't mean that there is no situation at all. So the system is a bit like this. You can see various systems. They send the first group alarm to the central alarm management. The buzzer goes on, it flashes on the screen, and you push the silence. And this is important. When you silence centrally, you silence both all the alarms, your own alarm, the buzzer on the central system, and the buzzers locally. So that you don't need to run around like a scared rabbit or all over the bridge. Actually, on the largest bridges these days, they only employ people who can run the New York Marathon. and this has not become very well taken by some of the American ship owners, who we know prefers hamburgers to marathons. So if you silence the buzzer locally, it will also be silenced centrally. But if there is a situation on more than one system, the other systems will not be silenced. So it's taking care of all of these things. The prototype, we ran up our automation system and navigation system and the electronic fire system and this central alarm management systems. So they are actually on 4 different computers and with different screens. So we'll see a bit more. And so we actually ran up all the alarms from the road, divided them into groups, and took it with the ship owner who preferred to be anonymous. In which way are we going to divide these alarms into groups? So this is interesting because these are the actual numbers. At the first 7 days, in the normal situation, there was from 2 to 59 alarms per day. At days 8 to 11, with the blackout and the alarm coding, there were thousands. The generator 1 and 2 both stopped about 20 minutes before the blackout. The diesel generator stopped at 04:10:21. Alarm coding started 04:10:22 with 237 alarms. 38 alarms the next second, 18 alarms the next second, 10 alarms the next second. In short, day 8, they had 6,426 different alarms. Day 9 was quite much better. It was 4,938 alarms, and day 10 was like sailing into the harbor of Hawaii. It was 1,407 alarms. So it was quite a cozy situation after all. I can imagine. So, navigation system view, automation system overview, and I must say that if you're not very experienced, it is a bit hard to see what's going on here, and even when you are experienced, somewhat experienced with it, it's hard to really see, is there a situation here or not? This is the alarm view when there is no alarm, and when there was a power blackout, yeah, oh, all right, you still have to look into it. There is 0, 0, 0, there's the alarm, 0, when there might not be anything on that day, blah, blah, blah. So when I ran these simulations for sailors, they didn't even care to look. They actually said, no, we never read those alarms, we never look into it, we have no idea. Really. And so it looks like this. What's going on there? But it's not only like that, it's a bit like the alarms flashing over the screen, and you're trying to read it, and there are thousands of them, and what the heck is going on? So it's somewhat confusing to quote the English word. So what we did is, we did this grouping, and tried to take all those almost, but it is like reading a language where you are not quite sure what it's saying. When we tried to put all these things into groups and so on, but we managed well, I think, with the ship owners and so on. We had our Excel sheet. We even noted how many times different alarms went on and so on. And we divided the automation system into, I think, was it 17 groups or something like that. So at the blackout, it would end up with this. And you could go into each group and have a look, what is the situation in this group. So here for the cooling, for instance, it was 8 different alarms. It was quite much easier to see what was going on. So we made this screen. These are the groups. They are equipment groups for the automation system. They are actually areas on the boat for the fire system and for the navigation. It was different systems like radar, ECDIS, spotting, landing, autopilot, the sensor interface, steering control. And this is where people can begin to think. I mean, the ship owners, the actual users, how will they prefer to have the groups made? The reason I put this boat on the screen was simply, what shall I say, psychological. We could see that if there was no boat on the screen, it was just a screen with boxes. As soon as the boat came on the screen, everybody naturally assumed that this is where I look. So it became natural. We had a soft silence and we had a hard silence, and we did various fun things. And we could follow here what happened. follow that something had happened in the feed water pumps, both of them, and the boiler began to pick up. And we did one thing that I think all alarm experts hate. They shudder. They sleep badly at night. They have nightmares when they have been presented this. It is because some alarms may be there, but the system is still working. For instance, you are going on uninterrupted power supply, you have an UPS. Okay, you should have an alarm, but the system functions perfectly. But you have to be alarmed about that. So those alarms actually made a yellow button. The alarms that told that the equipment had tripped made a red button. The seamen were overjoyed by that. And the DNP alarm experts were annoyed. So what I'm actually experiencing with this is that alarms, the definition of alarms, have not been understood properly. What it really is. And in the blackout, well, both steam generators, both diesel generators, has tripped. We see on boiler 2 there is a recurring alarm situation, so it's actually blinking at the time. The other ones, there are some situations there, but you know where to focus. And even though there is a very, very serious situation, you can notice that there is no fire involved. So you don't have to even think about the fire system when all the, and of course, it also becomes so silent that we're able to begin planning out what are we going to do now. And we see that planning on the UPS ran out on them. Because there are different UPSs with different requirements to how long they should be on UPSs. Green color means no alarm active within the group. The yellow color means the alarms are active, but the system, that system is still operating or operating. The red color means the equipment has tripped. It's not operating, it's not operating. Go do something with it. And the flashing color means unacknowledged verbal alarm within the group. But the thing is, these are the only mechanisms. They are very few, they take care of everything. If you want to see the group alarms, you just push, for instance, cooling, and you get up the window, aha, this is what's going on here. Aha, close it, go to next. Because what you do on board is you watch this, and you grab the phone and you say, hi chief, there is a situation, I see something is happening on the field of the drum, can you go downstairs and have a look? Right? And if many boxes flash, you take up the phone again and you say, hi, can you come up and help me on the bridge? There seems to be a flurry of alarms. I take care of the alarm situation. You take care of the navigation. So we have to go with it. So it's so easy. It's so simple. I think some people are annoyed because it becomes too simple. It's too simple to be believed, really. So we have proposed a standard for alarm handling in vessel systems. It's an enhancement based on this NPD, Norwegian Petroleum Directive standard, because that was for process automation. But on a vessel, there are many independent systems, so we have to take care of their relationships too. We have proposed to standardize the alert filtering method using the first of group concept, and we proposed the centralized alarm management. It features the screen, and it shows the situation for the systems. We export these by standard protocols, and we have already inputted the research to IOOI and IEC, so let's say what they say. By following these principles, we made some calculations for this actual blackout, and we reduced the alarm flooding alarms, that is the sounding of alarm, with more than 90%. Actually, I think about 95%. I counted it, because it's good to have numbers. And we reduced the general operational scenario with more than 30%, and you cannot reduce the actual number of alarms further without losing necessary information. So that is, you filter only once, and we put the filtering locally. This is very important. And we made a prototype. So for those who ask, shall we have this screen on the bridge or in the engine control room? It can be wherever you wish. Flat screens everywhere. There will kids tell you where to handle it, but it should be on the bridge, it should be in the engine room, and it will be on these oil rigs that are building now. It could be in the cargo control room, it could be outside or inside the captain's hut, in the canteen, mess, or wherever. And additional functionality has got to do with command control for the ability to reset alarms. We are working on that now. So it's important that any ship owner wishing to use the CAN must require this alarm filtering from all systems, and there are many of them. And systems must at least communicate via network or serial with the enemy protocol. This is important. So this is the traditional alarm view. And we really looked into that. This guy been sailing for many years, captain, cruise ships. The rig said, no, I never really look into what it means because I can't understand it. So you always have to pull up something. So it's good that everything is silent because it really makes no difference whether there is a noise or not. And I was told recently that people for automation systems, they sit, maybe they are reading or something, and they have their hand is here, and when there is an alarm, point, silence. Another alarm, point, silence. Another alarm, point, silence. So that's the reality of it. So this is in our demo room simulator. In the middle, we have a holding screen, and we have the radar and ECDIS dual screens on the left-hand side of the holding, and then we also have radar and ECDIS on both these screens that you can see in front of it, but we use one of them as the CAN screen, simply because the radar and ECDIS are backward in so many places that you really have to use a lot of systems before you have to take that screen for the radar or the ECDIS. So it's a quick overview, it's easy to read, it's very stressless. So we are coupling alarms and routines. We say that we have a routine that for this equipment we call that version, etc. We filter only once, we filter on equipment and all rotation groups in general, and this is where the word lies for all those who will use this system. We use the shelving for the spurious alarms so that it will be timed, and it will pop up, let's say after 8 hours or 6 hours or the next day or whatever. There is a quick overview, it's immediate understanding, it's less sound and less stress, and there is situation awareness. So this is what I in general wanted to tell you, and maybe there are questions, but thanks for listening at least.
Very interesting. So, any questions from the audience?
I expected you.
I have a number of questions, but let me go through them one by one. Since this is a Mars-type environment, would your system be able to run on top of a Mars-type cloud?
This is actually the principles. The mechanisms, they have to be implemented. I don't know if they are implemented. You simply must go through the alarms and have one part of this alarm message that tells the group. And so it must be, it simply must be programmed in that way. So for any, I give the principles away. So, and then for those who wish to implement it, they just follow the, what shall I say, follow the recipe.
Then another question I have is, you talked about a CAM system. I'm aware of an IMO directive on bridge work management. Is that the same, or is it
No,
going the same way?
No, it's not the same. And I think we could take that in detail afterwards. Yeah. You know Ernest Røseth? Don't you know Ernest Røseth from Marintech?
No, I don't.
Research director. He's the one who is in IMO. And he was on the project. And he has brought these things into IMO for discussion.
But it hasn't been adopted yet.
No. It's only been adopted by our projects.
Okay. Last question.
Yeah.
This system, this CAMP system, is accessible by people who are on board.
Yeah.
There's no reason why you couldn't make a similar system accessible by people who are ashore.
No. Of course, you just have to rely on shore. And what we actually were thinking is that I think any ship owner would love to have this situational screen at home and very quickly see what's going on, assess the total situation, because the ship owner is not interested in that wall or that pressure sensor or that temperature or whatever, a beep here and a beep there, but the overall situation. Yeah. Yeah.
So have you been thinking about any logic of the business system for the alarms? For structuring and relationship between alarms? Sometimes some alarm may trigger another one, and so on.
The triggering problem is something that alarm experts have actually thought a lot about. And the logical outcome of viewing the alarms and so on. And I think that you can build a lot of those things upon this. This is very simple actually. It's so simple that it is embarrassing. I simply solved the problem. And what's more, it seemed that those people who are looking at this and trying to use it seem to find out very quickly where something is happening. And the need for a further decision support system to see the relationship between alarms almost feels like unnecessary. So it's a sort of revelation when you use this and you see the various groups being on after each other. And it's rather, it's very revealing how you grasp the situation without having any more complicated relationships between what will logically follow. If something happens there, then this will happen, and then this will happen, and we should find the root cause and everything. So it is a bit simple. It could be, you could do a lot more work upon this. So if you implement this and it becomes open for everyone to use, then I'm quite sure that some clever guy, cleverer than me, will find some new application. So this is just the basic and very naive and simple platform for it. But the one thing that I'm proud of is that old sailors who have been sailing maybe for 50 years and so on, tell me that, oh, this is just like around 1970, before all those systems came with all those alarms. So this is back to good old days.
Any more questions?
While I was listening to your talk, I mean, there are two other kinds of systems which came to my mind, operating system and the UOT choice that you had in there.
Excuse me, don't speak so low, so quickly, because there is echo here.
So when I was listening to your presentation, two other types of system came to my mind. One is the standard operating system of computers, and which generate huge data about what's going on there. And the other one was in aircraft, where the pilots do have some ground as well. Yeah. And I was wondering whether there was any pilot that made, or whether you can take any learning from these two other fields in your area.
I haven't taken any learning from them. It was so simple that I must say that I'm a bit embarrassed of it. So the aircraft is much more complicated. We had a little look into aircraft alarm handling, and I do think actually that we could have used these principles in a way in aircraft, but I will not push it. And for the operating systems, that's actually a different story, and it would lead me into my pet way of programming or actually doing systems. So we could talk about that afterwards, because I have a lot of ideas for it, actually.
And I had another question regarding these pilots who completely ignore the alarms going on in the cabin. And isn't there any kind of liability which would sort of cause
Any kind of
liability? Don't they feel responsible for looking at really what's going on? I mean, by simply ignoring.
I don't know if I understand the question.
We'll take it offline.
Yeah, we can take this. Yeah.
I think I can correct on that. I think what he meant is that what he meant is, I believe, correct me if I'm wrong, that would you be liable if you, as a captain or an operator, just ignore alarms? Well, that's an interesting thing that, as we understand it, because if nothing happens, you're really not liable. But if the whole thing goes up, there will be investigations and so on, and of course you can then eventually be convicted for negligence or something like that. But it's really not clear in any way where that borderline goes. I mean, it's more like the outcome determines the verdict, so to say. So we think that all of this needs to be looked into very, very carefully, because these are very big ships. They can cause very significant environmental threats, very significant threats to life, and it's quite amazing that we don't have a regime for alarm handling. So we welcome your work.
What I would say is that as long as there is an alarm situation, you will have it indicated here. And by the routines, you will also have an indication that somebody is working on finding out just that. And if the guy who is working with alarms says that there is nothing dangerous, but it can't be repaired until you put the alarm on the shelf, and then the box will go green again. But you have it on the shelf so you can see wherever there are active alarms that you should in some way be aware of. But if it is a situation that needs to be taken care of course, there is something taken care of. So all these things here will be taken care of. But you don't need the zone. You don't need the extra zone to tell you that there is still something happening here. Because the meaning of the alarm is to make you aware that there is something. And when you have become aware of it, you don't need a zone.
Any more questions? I have a final comment and a final question. We in the Marsa community strongly encourage Kongsberg and people Autonomica, because the fire alarm company, to consider to become Marsa compatible and make this technology available to the whole global market. Because this is exactly how we, without even having Marsa as a mandatory standard, but as a de facto standard and a growing ecosystem, we think that you, of course, having worked on this for a long time, you have a heads up on the competition, so you will definitely become a market leader across bridges, and we think that's the way to do it, because there is one common problem that we hear from all captains and crew that we interview, from super yachts up to the largest vessels, alarm handling. Everybody has trouble with this. And actually, as a small craft sea officer, I was pretty shocked that there are no standards. When we went to Chalmers and got our Class 7 certificates, we realized that there are no standards being taught at the university about alarm handling because they don't exist. And that's a pretty scary business, because it's after all serious, but it starts to flash red and green and whatever is going on. So, thank you. Yeah, so, the final question here.
Yeah, so the final question then. Do you have an alarm for polar bear attack?
I don't need it. My parents told me how to get rid of them. I got them too. So you see, when I was 5, I was sent off to catch reindeer for dinner. So I had to go into the woods zone and catch a reindeer, and occasionally a polar bear come out and so on. So you really have to use martial arts techniques on there. Because then you can very easily strangle him. So there you are.
Thank you.